Chapter 9, Estimating the Value of a Parameter Using Confidence Intervals. Section 9.1, Part 1, The Logic in Constructing Confidence Intervals for a Population Mean when sigma is known. Lesson Objective: Compute a point estimate of the population mean. This is the heart of statistics, inference, where we go from samples to make inference about populations. Lesson objective: Statistical inference. We will begin our work in statistical inference. That is, we are going to take information obtained from a sample to make inferences about the population. There are two main branches of statistical inference: estimation and hypothesis testing. In Chapter 9, we introduced the concept of estimation of the population parameters using confidence intervals. In Chapter 10, we introduced the concept of hypothesis testing. We will begin with the estimation of mu, the true population mean. X bar, denoted with X with the line above it, the sample mean, is our best point estimate of the true population mean, mu. Definition: a point estimate is the value of a statistic that estimates the value of a parameter. So, the point estimate X bar is a statistic. It comes from a sample that will estimate the population mean, which is a parameter. So here's a visual. X bar is going to estimate mu. If we were to look at another statistic, S is the standard deviation of a sample. It will estimate sigma, the population standard deviation. And as you'll learn in section 9.4, P hat is the sample proportion. It will estimate the parameter P, the population proportion. Let's look at an example. A social networking website allows its users to add friends, send messages, and update their personal profiles. The following represents a random sample, the number of friends for 40 users of Facebook. Find a point estimate for the population mean, mu. So here we have the 40 values representing the number of friends for each person. To obtain the point estimate X bar, we simply add all these up and divide by how many we have, 40. So X bar is a summation of all the x's divided by how many values we have. So this becomes 5,232 divided by 40, which is equal to 130.8. So the point estimate for the true population mean for the number of friends of all users of Facebook is 130.8 friends. But we know that taking multiple random samples from a population will tend to yield multiple values for X bar, each one a valid estimate for mu. This implies, of course, that any single estimate of mu is unlikely to be exactly correct. And this is called sampling error. And so what we need is a range of values we can expect would capture the true but unknown value of the population parameter. This range of values is called a confidence interval. In this last slide, we are going to introduce a quantity called alpha, which is called the significance level. In Chapter 10, we'll have more to say about what the significant level represents. For now, it's good enough to say that alpha is a number between 0 and 1. As you'll see later in Chapter 10, common values of alpha are 0.01, 0.05, and 0.10. Note that the quantity 1 minus alpha is called the confidence level. In our next video, we are going to define what a confidence interval is and how does the confidence level affect the confidence interval. Thanks for watching.